Okay, now we are going to have a look at applying everything we've done with derivatives to this idea of calculating tangents and normals. So first of all, why tangents, why normals, why do we care? What's going on here? So when I have a line or a graph, so maybe one that looks like that, just a line or a graph in any which way, there are two things that I can calculate about this using calculus. One is the gradient, one is the area. We've already shown how to calculate the gradient, which is dy dx, and that tells us the gradient at a specific point. So, say this graph here, this is some x cubed plus 2x squared, I don't know. Maybe that's what this looks like, maybe it doesn't, it's an x cubed anyway. If I differentiate this, then I get 3x squared plus 4x. And this tells me what the gradient will be at any point on this graph when I put in its x value. So say this value here was x equals 2. If I put 2 into here, I get 3 times 4, 12 plus 8. My gradient is 20 at this point here. That's an awful point to choose, but you get the idea. So we can take this one step further and we can use this to calculate the exact equations of lines that pass this point in different ways. And these are the two types of ways that can happen. One is this line here, and this line here passes through my point and just slightly touches the graph at x. Just very slightly touches it. So in this case, it touches it at x equals 2. And because it's following along this, because it is following along this same path here, it's following on the same path of the line, when it touches this point, its gradient is going to be the same as the gradient of my line here, because they're both at this point following the same line. If I zoomed in, it looks like that, and at that point they both look like straight lines. So a tangent is a line on my graph that has the same gradient as the point on the graph it is touching. So in this case, this tangent would have a gradient of 20. A normal, on the other hand, is a line that runs perpendicular to my graph, or perpendicular to a tangent at my graph at a certain point. And hopefully we know that the gradient of a perpendicular line is the negative reciprocal. Just to explain what that means, it means, again, if this gradient of this tangent here is 20, well, first of all, this line is going the other way. It's got a negative gradient. So it's going to be negative, but also it's going at different rates. This is increasing a lot faster than this is decreasing, and that relationship is 1 over, which is the reciprocal. So the negative reciprocal of my gradient at this point is the gradient of my normal. So now we've got those two facets of information, we can put all of this together and use it to find exact equations for tangents and normals. And I'm going to show you the easiest way to go about doing that so we don't get confused. Okay, let's look at this typical kind of exam question. Find the equations of the tangent and normal to the curve f of x equals 12 minus 4x plus 2x squared at the point minus 1, y. So at the point where the x coordinate is minus 1. Well, there's a couple of ways to do this, but what I often find is people get confused between when they're using the gradient, when they're using the standard version of the line, where does this minus 1 come into play? So we're going to work through it slowly and break it down step by step. Now, the first thing that I want us to keep track of, and I'm going to do this in a little table down here, is the original, the OG, which will be this. So that is f of x and minus 1y. That is my original information. And then my I should call it derivative. So my gradients, which is going to be my f prime of x, and also my minus 1 and my y. And the reason for that is because this point will exist on both the gradient and the standard curve. But sometimes it gets confusing as to which one we need to use when. So let's have a look. Very first thing I want to do is I want to eliminate an unknown. Well, the only unknown I've got at the minute is this y here. And that's very simple to eliminate. I want to find the coordinate of the points on my graph where x equals minus 1. So if I don't have my y value, that's always a nice place to start, just so I've got it. So obviously I can rewrite this as y equals 12 minus 4x plus 2x squared. I know that x equals minus 1. So if I pop that in, I get y equals 12 plus 4 plus 2 times minus 1 squared is just 2, which is 18, not 16, which is 18. 12 plus 1 plus 2 is 18. So I know that my coordinate of this point is minus 118. That's just a nice place to start. It's something easy that we can manage to do. I'm going to rub this out because that's not going to be very important from here on out. Now, I want to go about finding the equation of the tangent and the normal. So let's start with the tangent. So, first thing to notice is a tangent and a normal are both straight lines. If they're both straight lines, then we know we are going to want something that looks like this. Y equals mx plus c. So, what information can I get? Well, with a tangent, I know that my gradient, which I'm going to write as dy dx, is the same as the curve at, and remember the point I'm working at is minus 118. Because this curve, this quadratic, it's going to be that shape, and at every point on this curve, it's going to have a different gradient. I'm interested in the gradient at minus 1. And I know that the gradient of my tangent, dy dx, which is of course m in this case, is going to be the same. So let's find that gradient. How am I going to do that? I'm going to differentiate my original expression. So my f prime of x, which remember is the same as dy by dx, is, well, the 12 is going to disappear. My minus 4x will become minus 4, plus 2x squared is going to be plus 4x. And I know that x equals minus 1. So if I pop this in, I get minus 4, which is minus 8. So I get that my gradients at wherever minus 1 is, might be somewhere there, on my curve is minus 8. Which means the gradient of my tangent at this point is also going to be minus 8. So I'm onto something. Now I need to find my c. Well, what do I know about my tangent? I know that it passes through my curve at the same point as what we're working with, right? That's the idea. It passes through the point minus 118. So I know that minus 118 must lie on this curve. So I can have a y value of 18. This is a weird angle. 18. I know that my m value is minus 8. My x value is minus 1 plus c. Ooh. And if I rearrange this, then I get, right up here, 18 equals 8 plus c, and c equals 10. So my final equation for my tangents is y equals minus 8x plus 10. Okay, now let's do my normal. So once again, I know that the normal is a straight line. So I know I'm working with y equals mx plus c. But in this case, the m is not going to be the same as the curve, it's going to be 1 or minus 1 over that gradient. So if I were to start this again, just imagine we hadn't done the previous bit, I would take my curve, differentiate it, put in my minus 1, all into just the, put in the minus 1 into the differentiated bit over here, and I will get my gradients. And the reason I've got this here is because so often people will put the minus 1 into the original equation. But putting the minus 1 into the original equation just gets you a y value. Doesn't get you a gradient. Always remember what you're being equal to. That is the key thing. This is equal to a y value, or an f of x value. But when I differentiate it and I get f prime of x equals minus 4 plus 4x, this is equal to a gradient. So I want to find the gradient, I put in my minus 1, and once again, I get that my gradient at that point is minus 8. But because it's a normal, that my m value is not going to be minus 8, it is going to be the negative reciprocal of minus 8. My minus and my minus cancel, and I just get 1 over 8 as my m value. Now I want to find my c value, and once again I know that my normal goes through the point minus 118. That's the point of it telling me to find the tangent and the normal at this point. So if I put in this information again, my y is 18, my m is 1 over 8, my x is minus 1. So if I do all this, I get 18 equals minus 1 over 8 plus c. So I get that c is 18 plus 1 over 8, which gives me 145 over 8. So my final equation I will replace up here for lack of space is y equals 1 over 8x plus 145 over 8. Or to make things a little bit easier, I can multiply through by 8 and I can get 8y equals x plus 145.